Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games. Welcome back to making a 3D wizard game, Zelda-like in GameMaker. So far, the product of the first 2 weeks is that we've got a basic 3D projection going on and some deferred rendering geometry buffers. And today I think I will be starting to do some more interesting things with this deferred rendering geometry buffer system and get lighting in the game. I wasn't entirely sure last time what was going to get done between like lighting and some other shader effects and water and whatever. I've decided I'm going to do lighting this time because it's definitely a little bit more important than those other things, and I'd like to get that squared away as soon as possible. Some things of note is that one, apparently I am not correctly clearing the depth and the normal buffers, and I thought I did that at the end of the last video, but apparently I forgot. So let me go and do that before I do anything else. Do we have a pre-draw where we're setting up any of these surfaces? No. If I minimize the game and bring it back, it'll probably just like crash, won't it? I guess I can do that here. Actually, if I draw clear after setting these. After setting the extra surfaces, will that clear all of them? It actually will. Okay, that makes my job easier. I don't have to worry about clearing all of them individually. Definitely saves on some operations right there. All right. That in and of itself is probably worthy of a commit. So some things of note, probably the biggest elephant in the room at the current moment is that GameMaker, in a recent beta, added support for other surface formats. A couple of these will be potentially useful for deferred rendering. I have actually not gotten a chance to play around with these as much as I'd like. I'm pretty sure I know how they work and how they're going to work in GameMaker. Probably once this leaves beta and hits stable in the February 2022 monthly release, I'll get around to getting this in the game. And this will save us some amount of trouble when it comes to things like encoding depth as a color, for example. It'll become much easier to do that with one of the the Surface R32 float surface format. But we'll get to that at a future time. So for now, lighting. So I'm going to use a lighting extension that I wrote a number of years ago for 3D in GameMaker for this. It is called Luminous Chickens. I will have a link to the itch.io page where you can find it in the video description if you want it. This system was set up for forward rendering, so I'm going to have to do a bit of messing around to get it to work with deferred rendering. Namely, I'm going to have to... it expects all the data to be coming in from world space, and I'm going to have to transform like the lighting data and the lighting direction and everything from world space to view space. And also, I'm just going to have to mess around a little bit in the shader itself and get it to look at the normals that were taken off of the G-buffer surface and the fragment depth that was taken off the G-buffer surface and that sort of thing, instead of using varyings that were passed in from the vertex shader. And this, I suspect, is going to be some code that's going to look really weird and arbitrary if you're not, like, intimately familiar with how it works. And I'm going to try and get through it as quickly as possible. And I'm going to hope that once this is done, I'm not ever going to have to go back to it, at least not until I possibly add things such as depth of field or SSAO or whatever. And, well, I guess if you have any questions about how it works internally, you can go ahead and ask them in the comments and I'll probably answer them. Otherwise, let me see how quickly I can knock this out. I haven't gone ahead and, like, done this ahead of time, and there's a part of me that thinks I probably should have, but, I want to minimize the amount of, like, devloggy, this is the stuff that I did off recording, except for monotonous stuff, like importing a million models into the, like, model creation tool or whatever. So let's just see how quickly I can go through this. So my unified lighting shaders that I've written in the past, going by the name of the Luminous Chickens, I don't want to rewrite my entire lighting system from scratch, supporting things like directional lights and point lights and spotlights and that sort of thing. But at the same time, since I am using a deferred rendering system, I can't quite just drag and drop this extension into my project the way that I would prefer to in order to save some time. So what I'm going to do instead is I'm going to copy the relevant lighting shader, the relevant lighting code. I'm going to go into shd deferred, and I will paste this here, and we're going to start just adapting this for use. Hopefully this won't take too long.
Hey.
I don't want this to take too long. We've got some inputs. We've got the view space normals, the view space depth, and the view space position, which should be all that we need to do here. All the values that we need to correctly calculate the lighting values. There's also a bunch of uniforms over here, which are going to need to get passed in. The max lights macro, I'll make that 16 for now. There are a couple affordances that needed to be done to make this work on both Windows and HTML5, and some other things that I'll just get rid of for now because I'm not interested in HTML5. If it becomes a problem when I try and build this for Linux later, I'll address those then. The old main function can go. The let's see, old no alpha testing will happen here. Old varyings, those can go. Is the pi macro used anywhere in here? Like specifically in the shader? Nope. All right. So it's not doing any harm. I was just a little curious. Let's see. These varyings can go. I did say that. All right. You know what? Let me just prefix all of these uniforms with U underscore just so that I can tell at a glance that they're uniforms. Because that is one of those code style things that I've adopted in recent days that I think makes my code a little bit easier to read. So that's one adaptation that is going to be made here. Another major one is going to be things such as the fragment attributes that were just passed in via uniforms. In the original Chickens lighting shader, these are going to have to be parameterized in some way so that we can, work with these values instead. So we're going to need to take the normal, the depth, and the position and view space, and I'm going to pass those into these to this lighting function as a parameter. So this can be one vec3. This probably should be in vec3 so that it's passed by reference and not copied onto the stack. I'm going to call that frag normal in vec3 frag position in float. In float doesn't make any sense. Float frag depth. And I'll make the font size bigger. Usually remember to do that before I start the video. Let's see. So I'm going to need to take all references to the normal varying. Replace it with the parameter over here. There is a world position that some of these use. That's going to be this one. I can replace that with U, and frag depth. As in from the camera and view space. That can be simply this value. And this function declaration is going to have to go at the top, isn't it? Since the code itself is going to be defined down there. And I should be able to, in theory, say common, light, and fog on the color that is just the diffuse color. I'm going to need the fragment normal, the fragment position, and fragment depth. This should at least compile now. It won't do anything. Light ambient color is also a uniform that needs to be prefixed with that. It won't do anything because we're not actually sending any light data. And if this is working as I'm expecting it to, the reason that the screen is black is because it thinks that there are no lights in the scene and the ambient color is set to black. Hopefully all the math is correct. And the next thing I'm going to need to do is, well, one, do source control things, and two, I'm going to need to add the rest of the the lighting, the lighting extension. which will allow me to like set lights and enable and disable lights and send them to the shader and that kind of thing. And I probably can all right, chickens.yyMPS. I can import this as an extension. I'll have a link to the to this extension that I made, this lighting extension that I made, in the video description, if you want to mess around with it yourself. Only bringing over the scripts. The shaders, I probably don't need the shaders. When it comes to applying this, however, I will need to... let's see, we can get rid of that because alpha testing won't be a thing in this... in the deferred shader because alpha isn't really used. I'm going to need to add the u_ prefixes to all of these. And at some point, I will also need to, like, convert all the positions and normals and stuff into view space, which I can do. However, let's do one thing at a time. OS type is Windows. I did say that I would initialize that light count to 16 for now. If I need to make it higher, and I suspect I will eventually, I will increase that to a larger number of lights. You can't have it infinitely huge because there's a finite amount of like uniform data that you can send to a shader. 16 sets of 3 vec4s should definitely be allowed though. What exactly do you do when you say light set light direction? So that's going to... So we're going to set a certain index to the light type, and when I send those to the shaders, I should be able to just check this value, and like based on whether we're looking at a directional light or a point light or a spotlight, I should be able to read that and transform the positions and or normals appropriately. This is going to need to be I plus 3, like this. Directional lights, point lights, and spotlights are going to all have slightly different values that they need to transform into view space. So directional lights are obviously just going to be a direction vector. So we'll just take this vector 3, multiply it by the view matrix to go from world space to view space, and then use that value. Transformed direction can be matrix transform vertex. The matrix can be... I'm going to pass in the view matrix as a parameter to the apply function. Alright, the matrix in question is going to be the view matrix that we set up at the top, the view mat that we set at the top, I guess. X is going to be the first 3 values in here, so this index 1, index 2, and index 3. And W is going to be 0 because we are transforming a vector and not a position. And the view matrix should be like orthogonalized. So when you transform a normalized vector by the view matrix, it should still have a unit length of 1. However, I am paranoid. So I'll do that anyway. And then I'm going to have to feed these values back into the Really, GameMaker, is like multi-line copy and paste just gonna not work now all of a sudden? Put these back into the array where they came from. So light primary index 0, 1, and 2. And that is going to be our transformed directional light. Next, When it comes to point lights are going to have something similar going on, but this value is going to represent a position instead of a direction, assuming that I was correct when I was looking at this earlier. Yeah, so index 0, 1, 2 in this first array of values is going to be a position instead of a direction. So the only change we have to make here is set the W coordinate in that transform to 1 and not normalize this value. That would make things a little weird. If you normalize the light's position, I have made that mistake before. And the spotlight, that is going to be the same. The first couple values, and that is going to be a position, but we also have a direction in the second array, so indices 4, 5, and 6 in the like the master array, and spotlights are in a sense a bit of a combination of directional lights and point lights. So because some of these light types have up to 12 values that define them in total, and because some platforms do not like it if you try to do something like access index I plus 1, I plus 2 in an array, I did have to break this up into 3 arrays of vector 4s, just to like minimize the amount of pain on like OpenGL platforms and whatever. I think that was also like largely driven by HTML5. I'm just gonna leave a comment here. And that should be everything I need. That should be all the transformations that I need. Let's see. It's a nice warning up here about using a shader that's not compiled. Let's see. I'm gonna commit this. This can be added added some of the other chickens scripts. I enjoy calling it that. And now let's try testing this out. So I'm going to need, you don't need any initialization besides what I did earlier, setting the max lights to 16. For example, I guess since this is all being done in post-draw, we can say this is going to have to be after the deferred call. First, cluck apply. And I'm also going to want to, for example, cluck set the ambient light. Why was it not giving me like control space code completion help when I hit control space? Whatever. Let's go with something like a medium gray. 40440 is probably good. And if I run the game now, we should have that ambient color instead of black. All right, cool. So we've got that ambient color. That's working. That's a good sign. And if I say cluck set light point to index, let's say index 0, the color can be C white. X can be, let's say, 250, and like 32 units above the ground. Oh no, wait, this is a Y up, so it needs to be the last two reverse. The radius, let's make this like 160 or so. Radius inner is optional. And to have it being tested, let's do another one, but instead we'll make it like C_red, and we'll have it at like 400 on the X. And that should give us something. Nope, that did not give us something. Illegal argument type. Why is the... Oh, it's because I'm not giving you a view matrix. What is the camera's view matrix? So this is going to be self.camera. I think get view mat. It is. All right. Okay. So barring that, this should work. And we've got something's not being transformed correctly because that light is like moving around, which isn't really intentional. We've got light and everything, but we are... Okay, you know what I am doing, and I suspect this is what it is, but I am actually like overwriting the first value in this array over and over again, which is going to, one, make the first value in the array incorrect, and two, make the like subsequent values in the like the different arrays not relative to view space. So I need to do something like light count times 4 plus that to make sure that we are like looking at the correct position in the array for each light. Because I'm lazy and I don't feel like typing that out all the time, we can say that to a variable up at the top of this loop, and we can simply refer to that index, and then all of the locations which we put values back into when we adjust them can be relative to that, like, to that starting index. Okay? And that should... This may or may not be the only problem that was at hand. It's still, like... It's better, but it's not like completely fixed. Man. What happens if I implement fog? If I implement fog, will depth work correctly? Set fog. Fog enabled. Enabled color, strength, start, and finish. Enabled is going to be true. Color can be, let's make that white. Strength can be 100%. Or 1.0. Start can be, let's say, 100, and finish can be like 500. Is fog going to work correctly? If fog works correctly, that means that we're at least calculating these, like we've at least got the depth correct, and it may just be a matter of making sure the view space position is correct. All right, fog is working correctly. But the light is still like, it's doing its best anyway. It's like it's moving around when I rotate the camera. Okay. So that at least narrows down the possibility of what might have gone wrong a little bit. I'm gonna push the fog a little farther out, just so that I can see more of the world before it vanishes before my eyes. Yeah. So after a bit of playing with math, I got the view space reconstruction like almost correct, and I've decided that it's not completely correct. You can see when I turn the camera, the position of the light changes slightly, and that actually appears to be a bug that was in like my original like deferred rendering videos, which is something I should probably like write a PS about in the comment and pin the comment so people know about it. But anyway, I've decided that the path of least resistance when it comes to fixing the view space reconstruction is actually to just like avoid the problem entirely and to go back on what I said at the beginning of the video, and instead of messing around with GameMaker Studio 2 February betas at a future time, I'll just do that now. And that will allow us to, among other things, store the view space position directly. And we won't have to worry about all the math involved in reconstructing it, and we won't have to worry about, well, honestly, a lot of things. So that's just going to make my life easier. So let me actually close that again, I guess, and open up the project in the 2023.2 beta. And, let's see, I was in here experimenting a little bit off the record, just to make sure that all this worked the way that I like think that it works. Really? Will that just not run? It runs. I don't know what those red lines are about. Anyway. Let's see, so there's a few ways a few changes I'm going to have to make. One of them is going to be the depth surface. And let's make that font size a little bigger. I need to specify a format for this, so there's a couple of them. Surface red 16 float, so that's a single 16-bit float. Red 32 float. Red 8U norm, so that's basically what we have now, but with the red channel only. Red green 8U norm. The one that I'm interested in is RGB A32 float. This is going to store a little bit more data than a regular GameMaker surface would. This would allow us to store a 32-bit floating point number for red, green, and blue and alpha each. And that is basically 16 bytes per pixel instead of 4 bytes per pixel. And that's going to increase the surface memory that we need and the surface bandwidth by a little bit. But I shouldn't be making anything so complicated in this game that we really take a hit from that. The first thing I'm going to do is go into the gbuff main shader, and that's actually where we are now. And instead of saying get depth as color, I'm going to write only the view space. Let's see, view space position .rgb. That's a vec3, isn't it? So the .rbg is like redundant. And I'm going to give that an alpha of 1. We still want the alpha to be 1 because alpha blending will still happen with these extended surface formats. And when I run the game now, we're going to get some funny looking answer on the... apparently we're not. Did I forget something? And I was learning the hard way that GameMaker, sometimes if you have the same project open in multiple IDEs at once, because I forgot to close it in 22.20, whatever the other one I had earlier was. And that was causing this project to not save and say that it was, or essentially it was causing the project to be like overwritten by the version that was in the other IDE, and that was a big problem. Anyway, we are now writing simply view space position to GL frag data index 2, which is the depth texture right now. And let's see, in the deferred shader, we can take that and we can say frag position is just going to be directly the whatever is sampled off this texture. And we don't have to do any conversion, we don't have to do any like get from VS depth or anything like that. We can just say, for example, call position equals this. Fragment position is call position, or if you don't want to be redundant, you can just get rid of that. Honestly, you can just get rid of that also, because depth itself is no longer being encoded in a texture. And I suppose just for the sake of like not being super redundant, frag depth really can just be derived from view space position, because frag depth is really frag position and view space.z.
Hey.
And from here, everything should you shader compiler didn't like that. Vec4, Vec3, Vec3, and I'm giving you, oh, that's a Vec4 RGB, or .xyz, or whatever. They're a union type to the shader. RGB and XYZ are the same thing. Okay. That is not working. Why is that not working? Am I not writing VS position correctly, or am I... Oh, this also got, like, erased. Surface. RGBA 32 float. Okay. Yeah. When I was playing around with that, like, having multiple IDEs open at the same time issue, that got erased also. Anyway, when I move the camera, you can see that the lights in view space stay where they belong. So we've got the red light on this chest, we've got the white light on this box. That is good, because that is working as I wanted it to work. We've got all these red warnings. I probably wish there was, like, a way to make those go away. I'm not signed in, because I don't, like, want my email to just be hanging around at the top of my screen at all times.
Hey.
Anyway, we can actually take this a few steps further. So because I am not including the normal as a vertex attribute, I now that I'm just storing v-space position, I actually don't need the normal gbuff like at all. That can be derived in the fragment shader, or in the deferred pass. I can get rid of this. I can get rid of this. I can also get rid of the like camera Z far values because I don't need that to convert depth. I can get rid of the field of view scale because I don't need that to reconstruct position. So I can get rid of a lot of this additional nonsense, which is like, even if I wasn't having problems with the deferred math not putting things where I thought they should go, that's a big reason to do this, because you can just get rid of a lot of additional junk. But let me get rid of everything that relates to frag data index 1 or vspace normals or whatever. I will take this and put that in the deferred pass because I will need that here. But we'll get back to finishing that off later. This uniform can go. These two functions can go. And boy, this really just is the video of simplifying a bunch of shader things, aren't they? VS position, that I need, these I need. Okay, I think we're good there. That doesn't have to get changed in any way. Samp normal can go. Get VS normal, all this stuff can go. Get normal from color. This is going to turn into get VS normal from VS position, which can be call position dot XYZ. We can get rid of sampling from the normal texture. Final color is the diffuse color, fragment normal, position, and I think everything else is good to go. And I think I can run this now, and I just deleted like 50 lines of code. Okay, not quite. Something's a little wrong. I have a feeling I know what that is, and that's going to be that I'm still sticking that surface in render target index 2. Yeah, that's a lot better. Okay, so normally I would not be doing all this in a beta version of GameMaker, using a feature that I'd only started messing around with like an hour ago. But today I'll make an exception. Surface RGBA 32 solves a lot of problems. RGBA 32 float. Alright, that was an adventure. I think, should I like add some more lights to here to test it so that I can like drive the point home a little bit more? Should I like add a directional light? Cluck set light spot, that can be light index 2, color can be like C, let's go with C yellow today. X can be, let's say self camera dot X, self camera dot Y, self camera dot Z. The direction that it's looking can just be like the direction of the camera. X2 minus. The range, let's give you a bit of a longer range. Let's say like 400, a bit longer than the range of those other two lights. The cutoff angle, let's give you a 60-degree cone angle and a 45-degree inner cone angle. And assuming this doesn't blow up in my face, because I've only actually tested, what was it, the spotlight so far. That should work. And it looks like something's not correct, so it's a good thing I'm checking that. I guess I should also check directional lights. Firstly, are you normalizing? You are normalizing the direction. Oh, that's right. I am doing some weird shenanigans over here to basically mask another value into the light type, so that I can like fit more small values into this without having to like add another uniform that I'm sending to the shader. That's cool. So to get around this, let's mod that by 16. And none of this was actually running because this value here was not ever actually like entering this case. But if I just look at the basically the lower the lower bits of that value, it should work. And we do indeed have something that looks a bit like a spotlight. The cone angle is a little wide, and it's hard to see exactly the like outer extents of it, but I can shrink the cone angle. Let's make it like 45 and like 30 degrees instead of 60 and 45. That should give us a cone that is, you can see the outer extents of it in the screen. And now we have ourselves a flashlight. This is our spotlight working correctly. Okay, that's great. We have deferred lighting working. That took a little longer than I thought it would, but at the same time, we got something done that I didn't think we would get done today, which is shoving off over to the February 2023 betas and using our new fancy surface formats and getting rid of a bunch of cruft and code, awkward bits of code that we don't really need. Anyway, that is probably going to do it for today. Let me commit this. I don't think I really have anything else to add. If I were to go and... Yeah, you can see some of the tabs I had open to do some sanity checks with the deferred rendering stuff. If I come back over here, I can check off added the chicken shader. A lighting interface. I added this card kind of forgetting that I'd already done that in the form of like light, ambient, light direction, light, whatever. A lot of what I had in mind for that was already done to begin with. There are a few additions I might make to that at some point in the future once I like get my bearings with like exactly how this game world is going to come together. I might like just, if there's going to be a lot of lights in the world, for example, queue a bunch of light values, and instead of giving them like an exact index, I'll just say like give each light a priority, and then like draw the 16 lights with the highest priority, or the 20 lights with the highest priority, or however many I end up going with. Skyboxes, S-part, water shader, ripple shader. Did not get to those today. Is this... Alright, yeah, I do want to check that off too. I'll do that next time. I can't think if there's anything else I really have a burning desire to do next time. Maybe, like, dropping in a skybox, dropping in S-part should be easy enough. Maybe if the other stuff doesn't take that long, I could write an extra bit of code around these to like give lights a priority and that kind of thing. We'll see. So let me end this off on this metrics thing. We're averaging 6 points of effort per week apparently. Estimated date to 0. Like 2 months from now? That feels unlikely. Oh, is that just for... Yeah, it's not showing the project as a whole. It's just showing the basic 3D rendering milestone, and I don't know why. Anyway, if you want to see the code here, look for the GitHub repository down in the video description. Look for the 0.3 release, which will contain everything I did today. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. Otherwise, I try to post about 2 game dev videos a week, 1 of these and 1 tutorial, so if any of this appeals to you, feel free to subscribe. I like to talk about things such as deferred rendering. I hope you all found that interesting, and I will see you all later. Special thanks to Army Armbuster, DJ Gibbles, Edward Holt, GameMaker, Gamer Player, Harold Guidry, Manta Ray, Sindra Larson, Squarecrow, Vitro V, and Zengiment for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.